Hello everyone. In continuation with the Fourier series, we'll be dealing with the period to pi kind of functions and in the interval minus pi to pi. And this is the second session for minus pi to pi 6. Find the Fourier series of the function f of x is 0 in the interval minus pi to pi and it is sine of x 0 to pi and deduce. So this is the first part of my question and this is the second part of my question. So I'm dividing this question into two parts. That means I need to address first the Fourier series. So I need to find out the Fourier series of this particular function. And second part is from the using the Fourier series of that function, I need to deduce this particular series. Okay, now this function has been defined as minus pi to 0, it as 0 and it is 0 to pi sine of x. Still, though the value of the function is 0 here, I have to consider the interval as minus pi to pi. I cannot consider the interval as 0 to pi because the value is non-zero here and here the value is 0. No, I have to consider the entire function, entire range from minus pi to pi. So this is minus pi to pi and it is compared with c to c plus 2l, then l is equals to pi. If you'll not following this, please go through the previous sessions so that you'll understand it. Every session is connected with each other, so please do not miss any sessions if you're first time visitor for this particular site or this session. And therefore f of x is a0 plus summation of a n cos of nx plus bn sin of nx. So I need to find out a0, an, b, write down this Fourier series. So a0 is 1 upon 2 pi integration minus pi to pi f of x dx. I'm putting the value of the function as 0 in minus pi to 0 and it is sin of x 0 to pi, and therefore this first integration will be 0 because of the function is 0 and therefore we have to just integrate the second. Integration of sin is minus cos from 0 to pi. It will give me 1 upon 2 pi minus of cos of pi plus cos of 0. We know that cos of pi is minus 1 and cos of 0 is equals to 1 and therefore the value of this particular function becomes 1 by pi and therefore we have got a0 as 1 by pi. A in the formula is 1 by pi integration from minus pi to pi f of x cos of nx dx. Then again this first bracket, because of this function value becomes 0 here, I've got this entire integration, first integration is 0. So I have to just deal with the second integral, that is 0 to pi sin of x cos of nx dx, and we know that the formula for this particular thing I can use it 2 times sin of a into cos of b is equals to sin of a plus b plus sin of a minus b. So we don't have it here 2, so we are just taking this 2 to the other side, sin of a plus b plus sin of a minus b by 2. What is a here? So the value of capital A in the particular thing is here as x and capital B as nx because it's just an angle, and therefore if you'll observe the sine of n plus 1 times x minus sine of n minus 1 times x dx, because I have just taken x outside, and so it will be easy for us to go for the integration. So integration of sine is minus cos of n plus 1 into x upon n plus 1 plus cos of n minus 1 x upon n plus 1 n minus 1. Why this has becomes plus here? Because it has already minus and sine, the integration of sine is minus cos, so minus becomes here plus. Integration from 0 to pi. Now why this condition has come into the picture? Every time I need to write down n equals n not equals to 1, because if we'll see the denominator here, this doesn't matter because it's n plus 1, but what will happen here if it is n equals to 1 for this particular thing? So if I'm going to put n equals to 1 here, it will give me 1 minus 1. So denominator becomes 0. So denominator becomes 0. So this entire quantity will go to infinity or not exist. And therefore, this condition plays very important role. That means whatever the value I'm finding out for an, that value is not true for n equals to 1. That value is not correct for n equals to 1 or not valid for n equals to 1. And therefore, we have to find out a1 separately. We have to find out a1 separately because of this factor. This factor has come in the denominator. If I have got here n minus 2, then it would have been n is not equals to 2. So this value of an will not be valid for n equals to 2. And therefore just we have to put the values of upper limit and the lower limit. Upper limit is pi, so every x has been replaced as pi, minus every x been replaced as 0 for this both the things. Just follow it, it's very simple. Nothing is there here to explain me. And therefore we know that cos of n plus 1 into pi is equals to minus 1 to the power n plus 1. Cos of n minus 1 into pi is equals to minus 1 to the power n plus n minus 1. This is same, we have got this two identities from this. Cos of n pi is equals to minus 1 to the power n. The same thing, instead of n, we have got n plus 1 in the first term, we have got n minus 1 in the second term. And cos of 0 is equals to 1. So we have just taken this help and we have wrote this particular step. So cos of n plus 1 is been replaced as minus 1 to the power n plus 1, and cos of n minus 1 into pi has been replaced as minus 1 to the power n minus 1. Very important step to remember and to understand. And again this n not equals to 1 will be there everywhere whenever we are having this n minus 1 in the denominator. And therefore this is the value of an, is minus 1 upon pi n square minus 1 into 1 plus minus 1 to the power n is not equals to 1. So that means what, this is the value of an for not, this value of an is not valid for n equals to 1. So we have to calculate a1 and or otherwise you can say this a1 here instead of an. I'm putting n equals to 1 everywhere here. So what will happen here if I'm putting n equals to 1 everywhere in this particular an? So if for n equals to 1, a1, the formula for a1 becomes 1 by pi 0 to pi, because anyways this is minus pi to 0 is everywhere we have to write down 0. So I've excluded that particular step and I've directly taken 1 by pi 0 to pi sine of x cos of x dx, which will give me this sine x into cos of x will give me this 1 by 2 sine of 2x dx, and sine of 2x, the integration is minus of cos of 2x by 2. Integration is from 0 to pi, because this is for the from the formula. Let me just write down. It's sine of x into cos of x in 2 times is equals to sine of 2x. This is the formula, we have used it here just to get this particular thing. And therefore it's 1 by 2 pi minus cos of 2x by 2, 0 to pi, and therefore it is cos of 2 pi by 2, cos of 0 by 2, and so if you observe this a1 becomes 0, and this is the value of an for not equals to 1. That means this value of n is valid for n equals to 2, 3, 4, 5 and so on, right? But that means this is not the value for n equals to 1, and we have got the value of n equals to 1 is equals to 0. So we have got this value of a1 equals to 0. bn, it's 1 by pi minus pi 2 pi f of x sine of nx dx. Then again this is 0 here. The second term I need to sine a sine b. So 2 times sine a into sine b is equals to this. So again this capital A for this particular is x, and capital B is equals to nx here, nx, and therefore we are going to get this as cos of n minus 1x minus cos of n plus 1 times x dx, because it's the formula over here. And therefore sine cos, the integration of cos is sine n minus 1x sine n plus 1x, right? And we know that sine of n minus 1 times pi is equals to sine of n minus n plus 1 times pi is equals to sine of 0 is equals to 0, and therefore ultimately everything will go to 0 here for this limits. For this limits, this will go to 0 for x is equals to pi and 0, and x is equals to pi and 0, and therefore I will be getting this is equals to 0. Again the condition is here, this value is not true or not correct for n equals to 1. The reason is because of the existence of this term over here. Otherwise, if I'm putting n equals to 1, it will go to 0, and it will go to 0, then this entire thing will not exist. And therefore, we have to take care of this entire thing very well. Okay, for n equals to 1, so I have written b1. b1 is 1 by pi into pi sine of x dx, which is 1 minus cos of 2x by 2. So again, let me just write down the formula for you all. So it's nothing but sine square x is equals to 1 minus cos of 2x by 2. This is the formula we have used it here. Trigonometry plays very important role for any kind of differentiation. So it's 1 upon 2 pi 0 to pi 1 minus cos of 2x dx. Therefore, it's 1 upon 2 pi x minus sine of 2x by 2 0 to pi. And this is, we are aware, sine of 2 pi sine of 0 is 0, and therefore we have got this as the function and the value of b1 as 1 by 2. So if you observe here, if you observe in the previous and the this step also, we have got b1 bn equals to 0 for the values n equals to 2, 3, 4, 5 and so on, but b1 equals to 1 by 2. b1 has the value as 1 by 2. Similarly for an, what we have seen that bn an has some value, whereas a1 is equals to 0. So we are just incorporating everything together to write down our f of x. So f of x would be a0 we have seen is 1 by pi, and if you observe an, we have got an, and see the difference how I have written this. It is n equals to 2. This value of an is valid for n equals to 2, and a1 is 0, what we have seen, right? We have seen that a1 becomes 0 for that particular slide. And here bn is 0 for all the values from n equals to 2, 3, 4, so on. But there is a value of b1 which we have written it here. The value of b1 was 1 by 2 into sine of x. Here the value of a1 is equals to 0, and we have written this n equals to 2 cos of nx, right? This is the difference and very important step to note it down. Okay, so if I'm writing it this as 1 by pi minus 1 by pi, let me just write down everything as n equals to 2 and so on. So if I'm writing n equals to 2 here, because this summation sign is starting from n equals to 2. So if I'm writing n equals to 2, this is minus 1 to the power 2 will be plus 1. So 1 plus 1 will give me 2. So it's 2 upon 2 square minus 1 cos of 2x, right? Plus, if I'm putting n equals to 3, what will happen? This minus 1 to the power 3 will give me minus becomes 0 here. 1 minus 1 will give me 0. So n equals to, this is the value for n equals to 2. This is the value for n equals to 3. So n equals to 3, I'm going to get it as 0. What is the reason? This reason is 1 plus minus 1 to the power n. This value becomes plus 2 if n is even, right? If n is even, and this becomes 0 if n is odd. So this is the value, or you can say that this is nothing but the flipping between 0 and 2, 0 and 2 and so on. Similarly, if I'm putting n equals to 4, what will happen? This will give me, the numerator will give me 2 and the denominator will give me 4 square minus 1 cos of 4x, right? And so on. Then this is the value for n equals to 4. I've written n equals to 5. What will happen? This will give me 0 and so on. So this is what is the chain, plus 1 by 2 times sine of x. This is the in between step between these two steps. I just wanted to explain, that is the reason I have left some space in between. And therefore it's 1 by pi minus 2 by pi, 1 by 3 cos of 2x plus 1 by 15 cos of 4x plus 1 upon 35 cos of 6x and so on, plus 1 by 2 times sine of x. Oh, so this is the deduction part, what we have to do. I think I hope it is readable for you. Let me just erase the little bit of part from here so that it will be yes. So this is what is 1 by 2 is equals to 1 by 1 into 3 plus 1 upon 3 into 5. It's not 1.3, it is 1 into 3. This is the way of writing the series. 1 upon 3 into 5 plus 1 upon 5 into 7 and so on. And therefore, if I'm putting x is equals to 0 here, why I need to put x is equals to 0? Because I don't want this particular step. Sine term I don't want. So this has to vanish. And the remaining terms, everything I want it, but with the coefficient as 1. So this should be 1, this should be 1, this should be 1. And this is happening only if I have got x is equals to 0. And therefore, what will happen to the RHS side, the LHS side? F of 0 is equals to 1 by 2, limit f of x from the left hand side and limit of f of x from the right hand side is equals to 0. For why we have to do it this limit case? Because the function has been divided into two. It is 0 and the function is sine of x, right, in the two different functions, and that is the reason we have to take the help of limit function whenever we are doing something like this from the left hand side and from the right hand side. And whenever I'm, so left hand side, that is a 0, it's already 0, the function has been defined already 0. What is happening in the left hand side? If I'm putting sine x as 0 here, so x as 0, so what will happen? Sine of 0 will give me 0, and therefore f of 0 is equals to 0. So if I'm putting everything here in this particular series, so what will be this? This is f of 0, 1 by pi minus 2 by pi, 1 by 3 plus 1 by 15 plus 1 by 35 and so on, which is been written as, or which is can be easily see that this 3 is nothing but 1 into 3. I can write down 15, I can write down as 3 into 5, 35 I can write down as 5 into 7 and so on. So this is what is the required series for this particular question. So we have addressed the second question as well. First was this was the first, that is to find the Fourier series expansion. Second was to find out or to deduce this particular thing. So we have addressed both of them. Yeah, and this is the self-observation slide. For this is 2 questions been given and along with the 2 answers. If at all you have any query or any question for me, please write in the comment section so that I can address those things. Yeah, thank you. Happy learning.